Here's a pretty straightforward problem where they're giving us the concentration of a strong acid and asking us to calculate pH. Since strong acids ionize completely when they're dissolved, whatever initial concentration of the acid they give you will also be the hydrogen ion concentration produced by that acid at equilibrium. Now there's going to be a little bit of a twist in part C. Let's do parts A and B together. These ones won't be difficult. So in part A, the concentration of the acid is 0.1 molar. So to get the pH, I just take negative log of 0.1, and we get 1. So the pH for part A is 1. For part B, negative log of, this time they give us 5.5 molar, and we get a negative 0.74. Yes, it is possible to get negative pH values. There's no particular reason why the pH scale stops, or there is no stop to the pH scale. Do note that 5.5 molar is quite a high concentration, and you don't often see concentrations much above that. But in this case, we do get a negative pH, and that's possible. In part C, here's the tricky one. You might start out by saying, okay, the pH of this solution would be, according to the format of the parts above, negative log of 1 times 10 to the negative 11th, and you arrive at 11. But remember that in an aqueous solution, the dominant species is always water. Water produces more hydrogen ions, in this case, than even the strong acid does. Because water autoionizes, the concentration of hydrogen in a solution or a sample of just water is 1 times 10 to the negative 7th. 1 times 10 to the negative 7th is a much bigger number than 1 times 10 to the negative 11th. In fact, it's 10,000 times bigger. So even though the strong acid produces some hydrogen ions, it's negligible compared to the number of hydrogen ions produced just by the autoionization of water. So in this case, the dominant contributor to the hydrogen ion concentration is water. If you were to take you don't even necessarily have to do this, but negative log of 1 times 10 to the negative 7th is 7, which is the pH of neutral water. So part C is 7, even though it's a strong acid, because of its really, really low concentration.